Now let's solve a problem on an AC circuit containing an inductor. So first of all, we can say problems on AC circuit containing an inductor. Yep. So problems on AC circuit containing an inductor. So here we have example. An alternating voltage (250 volts) and frequency of 10 Hertz is connected to an inductor of inductance an inductor of inductance 2 Henry for 1 minute. Calculate 1. The inductive reactance, and then 2. The heat dissipated in the inductor. So we have two questions here. So an alternating voltage of 250 volts and frequency of 10 Hertz is connected to an inductor of inductance 2 Henries for 1 minute. Calculate 1. The inductive reactance, and 2. The heat dissipated in the inductor. So here we have a solution. First of all, we'll have to write down the quantities given to us. The first thing is the voltage was given to us and it's 250 volts. The frequency is given to us and it's 10 Hertz. We also have time. The inductance of the inductor is given to us as 2 Henries, and then time is 1 minute, which is 60 seconds. You see. So now what is the formula for inductive reactance? Inductive reactance XL is given as 2 pi FL. Of course, 2 pi FL. Now, where 2 pi is constant, of course, pi being the rational number 22/7 or 3.142. F was given to us it's a variable, and it's multiplied by 10 multiplied by 2. Yes, 2. And so that means XL becomes 2 times 10 is 20 times 2 is 40. So we have 40 pi ohms. Of course, if you multiply this by the value of pi, you should get a completely numerical value of inductive reactance. So let's go to the second one. Here we have number 2. Find the heat dissipated. That's the question. Find the heat dissipated in the inductor. So here we have H, electrical heat, is given as IVT, but we know that I is equal to V all over R. You see, so if you bring it into this place, here we have H is equal to V squared over over XL. Of course, we are dealing with inductor in an AC circuit, and that means the R has to become, the only opposition to the flow of current here is the inductive reactance, which is XL, denoted by XL, multiplied by T. You see, so here we have H is equal to, what is V? V is 100, so we have 100 square all over 40 pi multiplied by 60. See, so this 0 takes the 0 out, and that means that we have H is equal to 100 square all over 4 pi multiplied by 6. So here we have 2 goes here 1, 2 goes here 2, 2 goes here 3. Then we have, okay, now 100 square is 10,000. That means when you divide 100 square by 2, you should get 5,000. So H is equal to 5,000 all over pi multiplied by 3. You see, so 5,000 times 3 should give us 15,000. Therefore, the amount of heat dissipated is 15,000 all over pi joules. I've given the answer in terms of pi, which is okay. You see, so here's a simple question involving an inductor in an AC circuit. So here we said an alternating voltage of 250 volts and frequency of 10 hertz is connected to an inductor of inductance 2 henries for 1 minute. Calculate the inductive reactance, and 2, the heat dissipated in the inductor. So here we have all the things given to us in a question except inductive reactance and the heat dissipated. So from here we know the inductive reactance is given us 2 pi FL, that's the formula. Now these two are constant. You see, it's more like the, how would you say it now? The slope of the graph, if you're to plot all this. Anyway, let's continue. So here we have 2 pi is equal to, what is F? F is 10 hertz multiplied by 2 henries. Of course, 2 times 2 is 4. 4 times 10 gives us 40. Then bring a pi here. So that gives us, that brings us to 40 pi ohms as being the value of the inductive reactance. Then electric heat is equal to IVT, but we know that I is equal to V over inductive reactance, and this gives us, if you put it in this equation here, we have V squared over XL, which is inductive reactance, multiplied by time. Of course, when you do all of that, we arrive at our answer being 15,000 all over pi joules as our answer. Thank you.